Okay, we're going to take a look at our graphing inequalities worksheet from the other day. We're going to look at number 3 first. I've got the equation here. I'm subbing in for -4. So I sub in -4 for y, I sub in +4 where both x's are, and then I simply calculate it. Let's put it all in my calculator. I can do it the long way here. I think I forgot a negative there on the -2, but 4 squared is 16. Following order of operations, I can multiply 5 times 4 is 20 and adding 6. So getting back -2 times 16 is -32 plus 20 plus 20 plus 6. And then is -4 less than or equal to -6? Is this a true statement? This is what you have to ask yourself. The answer, of course, is no. -4 is not less than -6. So it is false. It's not a solution of the inequality. It's pretty much as simple as that. Uh, Next, we'll look at number 6. I've got the equation here, and we're asked to match. So we'll make these a little bit bigger. Now, taking a look, I want to go less than or equal to, which is really another way to say that this graph is going to be included with all those points. We use this notation when we did domain and range, bracket versus parentheses. In this case, we're looking at solid lines. So A's got a solid line, it's a contender. D does not have a solid line, so it's out. B and E are both dotted lines, so they're both out, but C and F are both still in because they both have solid lines. Next, you really want to look at A. What does A do? Well, in this case, A is 1 or +1, which means the graph opens up. So I'm looking for the smiley face parabola. Going back, looking at my original choice A. Nope, frowny face, it's no good. Looking at C and F, of course, it's choice F. So there it is. That's our answer. You can verify things with -b/2a looking for the vertex. You don't need to in the case of matching. Do your process of elimination and finish out. Looking at number 12 here, 3x squared plus 4 is less than or equal to 7x. First, we need to get it in standard form, and an important thing to remember is keep a right where it is. A is positive right now. We just talked about how that makes the graph open up. So we'll move the 7x over 3x squared minus 7x plus 4 is less than or equal to 0. We do like to have you write the 0 or the y on the left-hand side, so I can move that over. And remember, it's pointing towards the function. It's going to remain pointing towards the function. So 0 is greater than or equal to 3x squared minus 7x plus 4. Where a is 3, b is -7, c is 4. We're looking to come up with some solutions here. So I'll go ahead and factor. Factors of 12 that up to -7 are -3, -4. I'll put those into our bubbles, but I do have to remember in this case, a is something that is not equal to 1. So I'll use our shortcut method and divide each of our coefficients by a, reduce if I can, in this case, x minus 1. I cannot reduce, so I'll move my 3 to the front of the x. So solutions or factors here, x minus 1 and 3x minus 4. I'm going to set each of those separately equal to 0. So I'll get x is equal to +1 after adding 1 to both sides. Over here, I'll add 4 to both sides. 3x is equal to +4. Then I must divide by 3. So I've got 2 points, x is equal to 1 and x is equal to 4/3. And what are these? Zeros, roots, solutions, and x-intercepts, all of them. So here's our number line, also known as the x-axis. And I can plot down with proper notation those two x values, 1 and 4/3. Remember, 4/3 converted to decimal is 1 repeating 3. I look for my test points, 0 to the left of 1, 1.1 in between 1 and 4/3, and 2. So for my 0 and my 2 outside values, I'll just go ahead and use my table function in my calculator. Punch it in, I'm going to have 0 comma something, 2 comma something. So those y values are 4 and 2. Easy enough. Then I have to determine whether or not I have a true or false statement. So 0 was greater than or equal to y value 4, or 0 was greater than or equal to y value 2. In both cases, the outside ors are both false. So what about our center? It should be true, but let's verify. All we have to do is write our original equation, not the original problem, but the original equation that we formed, and sub in 1.1 for both x's. And then I can put that all into my calculator all at once, and I just have to figure out is 0 greater than or equal to negative 0.07. And yeah, it's 0 is bigger than all the negative numbers. So there we go. That's a true statement. The truth is in the middle. So we've got a note here that A is going to open up, and this is a little kind of check for us about where we're going to be shading. Go to your vertex. Our original equation says y is greater than or equal to this function. Y greater than goes up, shaded in the middle. So now I could feel confirmed. I've checked it out with my little shortcut here. Here's my number line. X value 1, X value 4/3. Filled in circles because it is or equals to and makes it included, and shading in the middle. Not so bad. Let's take a look over here on number 13. We're looking at graphing this equation. So y is less than or equal to x squared minus 6x plus 8. There's a number of things you can start off looking for. I'm going to talk about some easy ways that are also going to help us get ready for the midterm. So A, B, and C, 1, -6, and 8, because I want to look for the vertex on the axis of symmetry first with negative b over 2a. Opposite of b is 6 over 2 times 1 is 2. So there's our axis of symmetry. So I know that that's going to cut that graph in half, and I know that my vertex x value is going to be 3. I can plug in 3 to the equation. I can go to my table to get a whole bunch of points. Either way, it's fairly easy to figure out that the vertex is going to be at 3, -1. But now I'm going to look at factoring. Going back to the top, a times c is 8, and b, -6, is in the bottom. Two factors are -4, -2. What's this going to give me? These are my solutions, my roots, my zeros. Oh yeah, they're my x-intercepts. So I can get some x-intercepts pretty quickly by setting both of those equal to 0 and essentially changing the signs. So I've got my axis of symmetry here going through my vertex 3, -1. I've got two x-intercepts. I've got 4, 0, and I've got 2, 0. So that really gives me the vertex and 2 points. So I've got 3 points. So if our 3-point minimum is met, 3-point minimum is met. I like 5 points, and there's another really easy one. It's the y-intercept. The y-intercept is 0, c when we're in standard form. So in this case, 0, 8. I can plot that pretty quickly on my graph, and then all you really need to do is reflect through your axis of symmetry, which is that x is equal to 3. 3 away from 0, which all y-intercepts have. So count over 1, 2, 3. That should be your axis of symmetry, and 1, 2, 3 more. And there's a new point that we've got, 6, 8. It's straight across from our y-intercept, and combined together with the two x-intercepts and the vertex gives us nice 5 points.